13 Bass Boosts Productions.
Hello guys, today we are going to be making a video about chemistry. I'll be showing it to you. So, before I start this video, I just wanted to say, please subscribe to my channel, Ryan Tech. And also, thank you for the support. Thirdly and lastly, I just wanted to say that in this series, we're going to be talking about chemistry. So, if I get tons of likes on this video, then I'll actually do more chemistry videos. And if I get tons of more likes with stuff like math, science, and many more, then I'll try going with educational videos. And if we also get tons of likes and I do more videos about chemistry, then I'll be making videos about biology and physics. So yeah, without further ado, let's get into it. So, first we're gonna be showing you the periodic table of elements. So as you see, we have Fe, and Fe is iron, and then at the top we have the atomic number. Okay, so on the top right, I'm gonna zoom it in a bit, okay, because I don't think you can actually see, but it's atomic number. It's a bit blurry, but at the top right, our atomic number is 26. Beside it, on the top left, is our atomic mass, and then the name is iron, and it says the chemical symbol is Fe, and Fe is iron. So the symbol is Fe, the name is iron. Then it shows the electron configuration. It also shows energy, and we're gonna get to that in future episodes because these are a bit too advanced and it's just waiting around the corner. So, but that's another time. So now, zooming out, we're gonna go into what's inside an atom. So an atom is basically like Fe, or let me just say iron, since it's actually iron, it's not Fe. But if we, for example, atom is iron. So an atom is one of these elements on the periodic table. So an atom could be hydrogen, lithium, it could be carbon, oxygen, nitrogen, helium, but I think you get the point. It could be any element, but it just has to be an atom of something. It can't be an atom of wood, because wood isn't on the periodic table. The element is basically something that makes an object. So like my point is, anything on the periodic table is an atom. Or we could call it element. Now, what's inside an atom? So now we're gonna be talking about protons, electrons, and neutrons. Okay, those are the three things that are in atoms. So, a particle occurring in all atom nuclei is a positive electric charge. So what this means is that a proton is a type of particle, okay? And it's a positive electric charge. So it's a positive electric charge. That means like in an atom, for example, like hydrogen. In hydrogen we have a positive charge, positive electric charge, and that positive electric charge is a proton. An electron is the same thing as a proton in a way, except an electron has a negative, so same thing, just negative. Now a neutron. It's a particle of about the same mass as a proton, but without an electric charge. So a neutron is the same mass as a proton, so it's as heavy as a proton, doesn't have an electric charge. So basically, that a neutron is basically like a proton and an electron, except not really. It's because a neutron isn't positive, but it isn't negative, It doesn't have any charge of electricity. Now, an atomic number. It's the number of protons in a nucleus. So you see the atomic number? It's actually the number of protons. So it's the number of protons in a nucleus. Now we'll explain some stuff like nucleus later, but it's basically the number of protons in an atom, for example. Like, just think of it as an atomic number is the number of protons in an atom. Just think it, or the number of protons in something, okay? Because we'll explain nucleus, nuclei, all those stuff later. Anyways, now here's basically a bit of a summary of these. So electrons, neurons, and protons are all inside of an atom because it's what's inside the atom, and we have protons, electrons, neurons, and yeah, those are the three main elements of an element. Except it's protons, electrons, and neurons are the very core of an atom. So an atom, because some people think an atom is the smallest thing, but no, it's because protons, electrons, and neurons and neutrons are what build an atom up. So if you have an element and change the number of neutrons or electrons, it would have the same element, except a different version. But if you change the amount of protons, the whole element would change. So let's say we had carbon. So there's different types of carbon. Carbon 14, carbon 12, carbon 6. So if you change the number of neutrons and you change the number of electrons, it would be the same element, just a different version. But if you change the amount of protons, they'll be completely different. So for example, if I had carbon 6 and I changed it into carbon 12, that means I did something with the electrons or the neutrons. Okay, so if you interfere with neutrons and electrons, it won't make any difference, just it'll change the version. But if we change the protons, then it would have a big impact of what is the element. And here's an example. So for example, gold, a yellow metal, has 79 protons. If we have gold and we add one proton, it will be Hg. Now I don't know what Hg is, because if I zoom in I can't see it, but I think it's mercury. Because I think I memorized it, because I always look at the periodic table. I even have one right in front of me, right beside me on my right side, and it says that Hg, it doesn't actually say what it is, but I think Hg is mercury. So if we add one proton to gold, it turns into mercury. So look, it says so it's mercury, and mercury is a metal. So now we're gonna be talking about the two things on an element. So I want to show you something. You know how we were just talking previously, I was just talking about periodic elements. So as you see here, we had atomic mass, which was 50. The atomic weight was something else, because we have the atomic mass, but for some reason on this periodic table it doesn't show the atomic weight. But there is such thing as atomic weight. Now you're probably thinking atomic mass and atomic weight are completely the same thing. But No, it's actually something different. Let me show you here. So, atomic weight and atomic mass. So I have this paragraph, probably 2 paragraphs, but I think that's like a paragraph. And we have this bit of a summary about what atomic weight and atomic mass are. So atomic weight and atomic mass is something that people assume it's the same, but it's 2 different things. So that's what I just said. And mass, so okay, let me explain what the difference is. So for mass is how much something there is. So you can measure mass with pounds or kilograms, even grams. Like you can even do many mass units. And then, so like, it's basically, for example, like if you want to see how much you weigh, you wouldn't say how much I weigh. You'd say, what is my mass? Instead of saying how much I weigh, you'd say how much is my mass. Now, you're probably wondering what is weight? Well, weight is how much the planet you're living on is pulling on you. So like for us, it'll be Earth. So it is a force. So it's how much force is pulling on you on your planet. Now, in order to measure weight, you have to use the term newtons. If you were in a place like somewhere without gravity, your weight would change because of the force pulling you from the planet you're on. But your mass wouldn't change because like no matter where you are, your weight is the same. And well, it depends, like in general, like you'll have to say mass always, unless you do something. So overall, like atomic mass is a measure of mass, and it's measured in atomic mass units, and 1 atomic mass unit is a very small fraction of a single gram. So now we're going into units of atomic mass. So atomic mass units are very small. Do you know why? Because atomic mass units are actually units they use for atoms. So just think about it. Like an atomic mass unit, if it's like near the weight of an atom, like if it's the weight of an atom, like atomic mass, then it would be so tiny. Because just imagine, if you carry an atom, you won't even realize you're carrying anything. Now anyways, let's go back to here. Oh yeah, okay. So this atomic mass unit is defined using carbon-12. And carbon-12 is a version of carbon with 6 neutrons and 6 protons. So previously we were talking about how electrons and neutrons, if you change it, then it changes the type and the version of element. That's basically like if you have carbon-6 and you change the things instead of putting it on, like for example, like if there was a carbon which was like 3 neutrons and 3 protons, but you changed it into 6 neutrons and 6 protons, then it would have been carbon-12. But like that's if you change it. Anyways, carbon-12 has a mass of 12 atomic mass units. Because you can see carbon-12 has a 12 of, because if you go on the mass units on carbon-12, it will be 12. But as you see here, carbon is 6. But that's because it's carbon-6. It's not carbon-12. If it was carbon-12, it would have been here. But this is the periodic table, so it shows the original like type of its being. Now let's go back. Mass. So this helps people and chemists to find out the atomic mass of an atom. The average weight of atomic masses is the atomic weight. So now calculation of atomic weight. So now we're going to be showing you how to calculate atomic weight. Now this part is a bit more tricky. So be notified if your age is the age where it's hard for you to do times and plus and times with decimal. Then you probably want to learn that. I might do a YouTube video about that. But anyways, let's jump into atomic weight calculation. So the way to calculate atomic weight is by choosing two versions of one element. So like we could have like carbon 12 and carbon 14, but I wanted to do carbon 12 and carbon 13. For example, like we could have carbon 12 and carbon 13. By the way, if you're wondering what carbon 13 is, it's an element with 6 protons and 7 neutrons. Then you'll have to find the percentage of that type of carbon on Earth. So carbon 12 would be like 98.89, and like that's the most carbon on our Earth. That's why it's a common carbon. Then you'll have to find carbon 12's atomic mass, which is 12.000. In fact, it's 12.0, but I said 12.000 because later when we calculate it, you'll have tons of decimal digits. And then after you do the same thing, but with carbon 13, which would be 1.110%, and 1.110% carbon on Earth, carbon 13 on Earth, then the AMU is 13.0034. And by the way, AMU is actually atomic mass units. So I just said AMU for short. So it's gonna be 13.0034. So what I basically did is that, so I said I found the percentage for like carbon 12. I found the percentage. Then I found the mass units. And then I did the same thing for carbon 13. And then I said 989% times 12, because it's carbon 12. So that's 12.0 atomic mass units. So I times both, and I added it by 13. So I added it by 13 because it was carbon 13 and it had 13 atomic mass units. So I said I plus these both, and then that's equal to the answer. I don't actually know what the answer is, so just for fun I'm gonna actually figure it out. So I'm just gonna paste this since I don't want to like waste 10 minutes of me like doing that. But like I'll just cut it out clips. Anyways, so this is the answer. So I'll just paste and copy that, delete the tab, and I'll paste it right here. So I'll go here and I'll paste it. So that's the answer. It's way too much of big font. But anyways, the point is that's how you do it. So you see the percentage of Earth it has, and then you see the atomic mass, and you add that with your second element, and then that's basically the formula. So the formula is percent on Earth, like E, like let me just say Earth, times, and then we'll do AMU, and then we'll plus it. So in fact I'm gonna put brackets here because you're supposed to times first. Then here's my formula, and then after that you're gonna do the same thing. So percentage, so you're gonna do brackets, percentage Earth, and then times AMU, bracket, and then it's gonna equal to like X, and let's just do N, and N is your number. Okay, so that's basically a formula. So now we're going into calculations. So we're gonna be talking about, so like there's only 2 more subjects left. but we're gonna be talking about the mole number, and then we're gonna go to here, and then we're gonna pause it from there, okay? So 2 more sections to go. Not much. So the mole number. So, like, not the mole that you have on your face, but it's a number. And the number is actually 6.02 times 10 to the power of 23. If you're wondering to the power of 23 or what it means, this is what it means. It means, so like 10 to the power of 2 means times 10 2 times. So it means 10 times 10. That's 10 to the power of 2. But if we have like 10 to the power of 23, it means we times 10 23 times. So it will be 10 times 10 times 10 ... Anyways, that's what power means. I'll post the video of math on that as well. This number is Avogadro's number. 1 gram is to a mole of atomic mass units, or you could say that 1 gram is equal to the mole number. So mole number is actually 1 gram. Okay, so let's say you have 1 gram of hydrogen, or it could be anything, like anything. It could be gold, it could be like carbon, it could be like boron, like lithium, anything. So like let's say you have 1 gram of hydrogen, then it's equal to 1 mole of hydrogen. Okay, it's like 2 hydrogen atoms. So if you have 2 hydrogen atoms, then it's equal to 1 mole of hydrogen and 2 hydrogen atoms. I know, 2 hydrogen atoms. The reason we know that is because, like, for example, like 2 hydrogen atoms has 1 atomic mass unit, which means if you take 1 mole of hydrogen, it will be 1 gram. Oh, hydrogen too, but I'm just gonna say hydrogen for short. Okay, now we're on our last subject, and it's mass number isotopes. Okay, I'm gonna be explaining this. So I'm gonna be explaining what isotopes, atomic number is, and mass number. I already explained the atomic number, I just wanted to be there, because it's going to include atomic numbers, so it'll be good. So 3 subjects: mass number, atomic number, and isotopes. In fact, 2. So atomic number, we went through that. It's the number of protons in a nucleus. So now we're going on isotopes. Okay, so 2 or more forms of the same elements that contain equal numbers of protons, but different numbers of neutrons in their nuclei. And I'm gonna explain nuclei in a different episode. And is a difference in relative atomic mass, but not in the chemical properties. So a short summary is that it's basically like it has to like have the 2 or more forms of the same element. Then it has to be equal to protons, but different numbers of neurons in their nuclei. So for example, like we can have like carbon and it's 2 or more forms of it, and then it has different numbers of neutrons in their nuclei, and is a different in relative atomic mass, but not in chemical properties. So it's basically 2 elements combined together, just like with different neutrons number and also different in atomic mass. Now, last but not least, a mass number. So mass number is the same. It's basically the number of protons and neutrons in a nucleus. So that wraps it up, guys. I just want to say it's been a long time since posting, but the thing is I'm a really busy person, okay? My calendar is full and stuff. So I just want to say I'm gonna try to post more. So have a nice day, and as always, see you soon.
That body's a blessing, girl. I ain't trying to pressure her. She messed with the temperature. Hard wrote the song, but I am the messenger. Through the metropolis.